See, dear students, in linear equations, our next point of discussion is equation of lines parallel to axis. Equations of lines parallel to x-axis and y-axis. See, draw the Cartesian plane. So in this Cartesian plane, these two mutually perpendicular lines intersect at O. So, okay, here the line XO X dash is known as x-axis and the line YO Y dash is known as y-axis. On OX you take positive real values. On OX dash you take negative real values. Similarly, positive real values, here negative real values. Now, any point on x-axis will be in the form of a comma 0, that ordinate will be 0. If it is the point on x-axis, the ordinate means second coordinate, abscissa means first coordinate. So, if a point lies on x-axis, that ordinate will be 0. If a point lies on y-axis, okay, the abscissa will be 0. Are you following? Please do understand, if a point exactly lies on x-axis, that y-coordinate will be 0. If a point that exactly lies on y-axis, its x-coordinate will be 0. So for every point on YO Y dash, you will see x is equal to 0. So x is equal to 0, you can say it is the equation of y-axis. Are you following? Now for every point on x-axis, okay, you can see that y is equal to 0. So y is equal to 0 is the equation of x-axis. Please do understand, once again I repeat this point so to avoid any kind of confusion in you. See, any point on any point on x-axis will have y is equal to 0, y coordinate will be 0. Any point on y-axis, any point that lie on y-axis, you can see that x coordinate is 0. So x is equal to 0 for every point on y-axis. So x is equal to 0 will be the equation of y-axis. Are you following? And y is equal to 0 for every point on x-axis. For every point on x-axis, y is equal to 0. So y is equal to 0 is the equation of x-axis. So I think it is very clear for you. So here I will write the things which you have understood. So equation of x-axis is y is equal to 0. Equation of y-axis is x is equal to 0, and the point of intersection of these two axis lines is 0 comma 0. See, axis is singular, axis is plural, ES. If you write AX ES, it is plural, AX IS, it is singular. Now understood? Now let us take the geometrical representation of a linear equation. So now we are going to see the geometrical representation of linear equation. So give the geometrical representation of the linear equation the give geometrical representation of, say simply x is equal minus 2. So give geometrical representation of x is equal to minus 2. Okay. So now here the two situations will arise. Situation 1 is if you treat this as linear equation in one variable. So solution, so x is equal to minus 2 implies x plus 2 is equal to 0. So which is linear equation in one variable. So if you treat this as linear equation in one variable, then its geometrical representation will be a point on number line. So this is the number line. So the geometrical representation of this linear equation would be the point on the number line, x is equal minus 2. Did you understand? Now, if you, this is when considered as linear equation in one variable. Now, when it is considered as linear equation in two variables, it will have infinitely many solutions. In the previous case, we have considered as linear equation in one variable. As we have discussed, it will have one and only one solution, that is x is equal minus 2. That will be a point on the number line. If you treat this as linear equation in two variables, then it can be written as, okay, 1 into x plus 0 into y minus 2 is equal to 0. 1 into x is x and this 0 into y is 0. So, okay, so here we have taken x plus 2 is equal to 0, right? X is equal minus 2 means we have taken x plus 2 is equal to 0. So 1 into x plus 0 into y plus 2 is equal to 0. So now if you draw the graph of this equation, okay, you will get various solutions. So the various solutions are among all these solutions, okay, that x value minus 2 will remain same and y keep on changes. You can take any real number, you say r. So where r belongs to r. So r is a real number. For any real number r, okay, this equation gets satisfied. So because you take something, so you take some value for r here, take 1, then what will happen? So minus 2 plus 0 into 1, 0, plus 2, minus 2 plus 2 is 0. So this y has got nothing to do because you are multiplying with 0. So this value has got nothing to do. This value when multiplied with 0, again it will give 0 only. So you change the value of y also, makes no difference because the product remains same. Though you change the value of y, the product remains same, it will be 0. So are you following? So various solutions of this linear equation in two variables are given by minus 2 comma r, where r belongs to r. Are you following? So if you draw the graph of this linear equation, so the graph can be easily seen here. See here. So minus 2. So this is somewhat minus 1, this is somewhat minus 2. So this is minus 2, 0. Okay. So now So this all see here above whatever the ray is going, so okay, it will have that -2 constant, that numbers may change, -2, 2, -2, 3, something like that, it goes upwards, and here this is -2, some -1, like, okay, -2, -2, it goes something like this towards downside, but that -2, x is equal -2 remains same. So the geometrical representation of the linear equation x plus 2 is equal to 0 when it is treated as a linear equation in two variable, then it is a vertical line. Vertical line means parallel to y-axis. So it is a line parallel to y-axis and okay, -2 units away from y-axis, or you can say it is 2 units left side of y-axis, makes no difference. Did you understand? Now another question I am taking. So first let us conclude this point what we have observed. Okay, so therefore conclusion is, okay, the equation which is in the form of x is equal to k, okay, the equation which is in the form of x is equal to k is a line parallel to y-axis. This is our conclusion. If k is positive, it will be right side of y-axis. If k is negative, it will be left side of y-axis. Understood? Now another question is, give geometrical representation of the linear equation y minus 4 is equal to 0. Again, when it is treated as linear equation in one variable, okay, then it is a point on the number line. Here that point can be shown here, y is equal to 4. Did you understand? Now if it is treated in linear equation in two variables, so you can write it as 0 into x plus 1 into y minus 4 is equal to 0. So here x can be any real number and y is equal to 4 is the solution for any r belongs to R. So now if you draw the graph of this second situation, see here. So this is x-axis, this is y-axis, this is origin 1, 2, 3, 4. Here our 0, 4 will be there, and if this line, please take this line. Okay, so for every point on this line, that 4 remains constant. So this is something like 1, 4, this is something like 2, 4, and this side, that 4 also remains constant, but that abscissa may change. Say this is -2, 4. Just I am taking rough diagram only. So -3, -5, 4, something like. Okay. So you see, each and every point on this line, you can see that y is equal to 4. Okay, so if you treat y is equal to 4 as a linear equation in two variables, then it is a line parallel to x-axis, and in this particular case it is 4 units above x-axis. Okay, so now what is the conclusion that you can give? The conclusion we can give is, any equation of the form of y is equal to k is parallel to x-axis. Any equation of the form y is equal to k is parallel to x-axis. Okay, and if k is greater than 0, it will be above the x-axis, and if k is less than 0, it will be below the x-axis. Understood?